Our presenter is Austin Little. Austin is a University of Illinois Extension horticulture educator. He covers Jackson, Franklin, Williamson, Randolph, and Perry counties in Southern Illinois. And with that, I will go ahead and let Austin take it away.
Good afternoon. Hi, everybody. Thank you, Maggie, for the introduction and for hosting today. So welcome back to the Greening Up series, and today is our concluding episode here for permeable pavement. So we're wrapping up this part of the Greening Up series. Maybe there'll be other Greening Up installments or could be a blog, but this is kind of the first run of this series, so thanks for joining. And we'll go ahead and jump into permeable pavers. So permeable pavers on the surface maybe don't seem as interesting as some of these other dynamic kind of rock and roll kind of green infrastructures like the green roof and kind of exciting and really kind of showy. These are a little bit more functional in a lot of ways. But they are an important and dynamic piece of the wider suite of green infrastructure. And it really does have a big impact on these environmental conditions and the quality of the built environment. So this is a little recap here. We kind of talked about this briefly in the introduction, but we'll just kind of go through this. So pervious pavers have come in a few different forms and shapes, and they go by a few different names, and we'll get into the details of what these specific differences are. There's kind of three main categories, but we have pervious pavers or pervious concrete or porous concrete and pervious or porous asphalt. And then we have a range of permeable pavers or blocks or even tiles. We might call them tiles, but these are all systems that are sustainable, and they're used for paving, and they allow for excess stormwater overburden or overflow to move through and around pavement, either through it or around it, to reduce or even eliminate stormwater runoff from buildings and impervious surfaces. So those impervious surfaces are going to be things like traditional concrete walkways or things that don't soak up water, rooftops, roadways, driveways, any kind of impervious surface like that. And so these are just a few of the key benefits here of permeable pavers and pervious paving. So the biggest one is urban runoff. So that mitigation and catchment of urban runoff or stormwater management. So by doing that, it improves water quality by filtering out pollutants and recharging the water table and recharging soil water. So by doing that through these kind of layered gravel systems, which we'll see, it helps to filter and clean water, stormwater. So this also reduces urban flooding by moving this water away from areas where it pools. So one good example, one of the main reasons here that this installment, this permeable paver section here was built, this is at Southern Illinois University, Carbondale, where we've gone on tours of these other green infrastructures, and we'll do a quick demonstration and tour of this one today. But the main issue was that we've got to the right, which you can't see, there's mostly hardscape. There's a very large college building there, the College of Ag, and it's flat roofed. And then we've got a lot of walkways. So there was water pooling along here against Thompson Woods, and it would be almost a foot of water sometimes that would be standing there where people would be. That's a major line of traffic, a major thoroughfare of foot traffic there. So that was a big issue that needed to be managed and addressed. And this was the way to do that. Along with over back here, we've got a rain garden that kind of comes along. And then on the other side of this. So this was an integrated system, but it really did a lot to impact and reduce the stormwater issues that we were having there, where it wasn't being controlled in the most efficient way, in an optimal way. So all of these things tie into improving the usability and accessibility of urban environments. So sidewalks, city streets, parking lots, it improves the amenity of all of these places. So doing this all ties into increased property value. When you improve the usability and the attractiveness of these otherwise kind of just purely functional systems or parts of the built environment, these features, by enhancing these, we enhance the property value. It's a place where somebody would actually just enjoy to maybe spend some time instead of moving from point A to point B. So that improves property value, and also the reduction in urban flooding definitely improves property value. And that's a big economic impact. So overall, we're improving our urban environments, and by urban environment, that's anywhere from a sparsely populated suburban area all the way to urban downtown. So we're improving from there to in that spectrum. We're improving streets, driveways, parking lots, homes, patios. All of those things are applicable for pervious paving. And there's quite an interesting history to permeable pavement. Permeable pavers were first put to use in the United States in the 1960s, right around the time of the EPA Act, the Environmental Protection Agency. When that was introduced or founded, it was necessary to address these kind of emerging urban stormwater issues, and that's really when that movement started. And if we fast forward to several decades later, in the 90s, permeable paving systems really started to boom and become in more interest in the United States, in places like Chicago, Nashville, any kind of metropolitan area that's kind of in the range where we get a lot of rain, is where these things really started to take off. So kind of too, in these this was a way to address this over paving issue that really started to become evident in the 1960s and 70s. And the earliest form of permeable pavement dates back to ancient times, back to antiquity. So Egypt, it goes back to ancient Egypt, really, where they knew that it was important to be able to move extra water off of roadways. So Romans really put this into effect with their paving blocks and spaces between them with either gravel or some kind of material that was pervious. Now, these themselves aren't very pervious or accessible for water. So we're really talking about the water moving in between these spaces. So this would be an early form of a permeable paving block system. And now if we move forward in time, a couple thousand years, we get to kind of the early modern adaptation of permeable pavement, and that began in Europe in the 1800s. And so in the very early part of that newer kind of wave, we have this is an example here of early permeable paving where it's really engineered to move water out of the roadways in a pretty efficient, fast way. And that was developed in the UK, and they were looking at using blocks made out of different aggregates that had spaces in between them, different sizes of space. So different sizes of aggregate or particles like rock or gravel mixed together into blocks. And so it was really an arising issue in Europe, where we had very crowded cities. During the Industrial Revolution, it was critical to get water, very polluted water, off streets as fast as you could, because it would quickly become a serious problem. And then it really came into more of a wide adaptation across Europe when they were trying to rebuild after World War II, trying to rebuild cities quickly. Pervious or permeable pavement materials were used not only in roadways, walkways, these kind of things, but also in building new buildings. So pervious, just lightweight materials that were used for load-bearing walls and things like that. And then, of course, moving forward into around the time of the EPA establishment, that's where it really began to pick up momentum in the United States. And so the first official guide for pervious pavement was created in the United States by a couple of landscape architects here in Philadelphia. It's called porous pavement. We can take a look here at this quickly. Check out this link. And if I didn't put this in the page of links that you'll receive, we'll get this to you, because this is pretty interesting. I mean, it's kind of complex and gets into the nuts and bolts, but it's pretty interesting if you want to take a deep dive into the early days of porous pavement development. Okay. So as I mentioned, there are three general categories. Whoops, lost our PowerPoint there. That's never happened before. Just a moment. Okay, here we go. So as I was saying, there are three general categories of pervious pavement systems. So we have porous asphalt, which would be used for walkways. Porous asphalt was developed in the 1970s, and it greatly resembles just non-porous asphalt that you would find commonly on roadways. But the difference is that what are called fines. So fines, if you hear me say fines, that's fine sand and dust particles that are used to bind that material together. But those have been removed to open up porosity and air voids that water is able to filtrate through. And so this type of pavement could be potentially used on lower traffic roads, but not highways. So not any of these systems are really applicable to heavy duty traffic with trucks and steady constant traffic of vehicles of different sizes, because of the lower kind of weight capacity or strength of these materials. But they are well suited for, say, a residential street, maybe where we've just got residential car and small vehicle traffic, footpaths, bike paths, parking lots, things of that nature. But highways, it's probably not applicable. And as we've kind of mentioned with porous asphalt, we have porous concrete. And porous concrete is pretty similar. It's much like the asphalt. Again, it has those fines removed to create those air spaces developed in the 70s. And this one is kind of more for driveways, even more limited traffic. Maybe you might find it on the side of a street where only cars are parking. So kind of the parking lane or bike lane, a mixture of those two, definitely used for walkways, driveways, and footpaths. So things of that nature, possibly even parking lots, but probably not for more steady traffic that would be like a through street. And then we have permeable pavers and blocks. And these are the most common systems that we're going to find in the kind of home landscape or on maybe a campus or public spaces, parks, those kind of places. This is what we might find at a school or a library, something like that. And so here's a couple examples here. This is more of a natural kind of rounded sort of stone with this aggregate in the middle. And this aggregate is what would be these finer particles. That's the permeable part. And then we have more of an interlocking kind of block system. So they have little nubs around here that create these spaces or seams where we have that aggregate in between that again allows the water to percolate down, and there is very likely a couple layers of different size aggregates of gravel to help with filtration, and then kind of water holding as well to help it move out into the soil layers. And those are the three main types. Now, one question I've had is a French drain considered permeable pavement. And that's kind of how do you look at the definition? How do you bend the definition? So in all kind of form and shape, a French drain is sort of like a permeable pavement system, but are we using a French drain as a pavement? So a pavement is something where there's some kind of traffic on, there's some kind of human interaction with, where we're walking on it, driving on it, riding bikes on it, it's being trafficked. So a French drain is really, I see it as more of a kind of a hydraulic infrastructure kind of thing, where it's more hydrology, we're moving water from one place to the other, but it's usually covered with some aggregate of rock, and it's really just to transport water. So in my mind, French drain has the qualities, the characteristics, but it isn't used the same way as permeable pavement. So just an interesting little tidbit there. I guess my own philosophy on permeable pavement. But and then there's some others. So there's yet some other more specialized types. So there are grid or turf reinforcing grid. It's the same thing. And so these are very commonly found in parking lots or kind of backyards or even driveways. And a good example that I couldn't find a photo of, and I wasn't able to make it up there. I wanted to go get some photos, but the Missouri Botanical Garden parking lot has a really cool parking area, an auxiliary parking area that has this grid system or reinforced grid where it's got turf in between here. So we've got the pavers themselves, which are not the permeable part again, it's the parts in between here, the turf, and then the spaces where water is moving through there pretty quickly and efficiently. So, and these have many different names and forms, including plastic geocells or reinforced geocells or plastic cells or turf cells, any of those. And this is a plastic grid pavement system where they've got an aggregate underneath of this, and they rake gravel over the top of it. And this grid is to hold that gravel in and stabilize it. And they come in sheets or cells, the plastic type, but these come in blocks, more or less. And so very popular for parking lots, trails, walkways, things of that nature. But if you're ever at if you've been to the Missouri Botanical Garden, you might have seen their turf grid that they have there. It's pretty neat. And and we'll talk about this whole integrated green parking lot system that they have. And actually, that's what we've got here. So let's talk about some interesting uses for permeable pavement. And so kind of that over pavement issue that we started to have in our cities, that now we're kind of having to take a step back and say, how do we kind of start to move in the direction of becoming a little more sustainable instead of everything just being paved over, because we're losing a lot of the ecological services of stormwater management and cooling our cities down. So it's a big movement to try to bring some of those environmental services back into the urban spectrum. And so green parking, this is a program with the EPA, and there's other initiatives for green parking, but we do have a link here to show, and it's in the links that you'll get sent to you. But I will show you this real quick, not that. So this is the Green Parking Lot Resource Guide. And this is a resource for kind of the program of green parking, or the kind of movement of green parking, if you will. And so it just talks about different approaches and practices for greening up parking lots and making them more sustainable. And permeable paving is kind of the centerpiece of a green parking lot, including things like rain gardens, trees, islands with plants that provide some kind of environmental service, solar arrays or solar panels, and even including things. So this is kind of landscaping for parking lots. This is green landscaping for parking lots, where we're even using statuaries or other kind of creative elements. Maybe there's interactive educational elements within the parking lot itself. So it's really, in the case of the Missouri Botanical Garden, this is out in their parking lot. So it's this first kind of exposure. You're right off the bat when you enter the parking lot, you're already getting engaged with these green infrastructures and kind of sustainable landscaping features. So it's really cool. You could just spend a couple hours out in the parking lot looking around. And this is another project. This one is in Canada, and this was kind of I suppose it was more of a trial trial run to kind of see the impact. So this was part of a study. This green parking lot was a study. So it's kind of an open lab teaching green parking lot feature in Canada that they've used to take data and to see kind of the quantifiable impacts there of green parking lots. And so this would be a permeable paving system parking lot. And so where might permeable pavement not be the best option? There are situations where permeable pavement will not be a benefit. And that's going to be, as I mentioned previously, really heavy traffic thoroughfares where you've got 1 or 2 lanes of traffic going each way, and it's just kind of constant traffic with trucks and other vehicles and highways. So again, it's just down to the structural strength of these materials. We're not at the technological stage yet where they can efficiently and effectively, cost effectively last for more than 5 to 10 years. It might get there someday. Hopefully it does, and eventually all highways are basically permeable. But as of now, that's where we're at. And heavy loading areas where we've got trucks loading in and loading out materials. Again, it's just down to the structural capacity and resilience. Then places where we're having high potential for hazardous spills, might be a gas station, something like that, where high probability or high likelihood of something toxic being spilled. For obvious reasons, we don't want that to soak down into the soil and possibly into the water. So that's why we would want to avoid those areas. And areas with a slope greater than 20%, there are ways to efficient or effectively use permeable pavement systems where it's kind of stair stepping. So the underlying layer is more of a terraced kind of form of aggregate, but on top it's a sloped surface. But those are a different kind of system. And in general, though, with these that we've talked about, just kind of laying them at a more than a 20-degree slope, you really lose. The issue there is that you lose the permeable quality and effect there. You lose the permeable kind of services there. And more water runs off than is absorbed. So we lose that benefit when we get into higher sloping areas. But there are certain ways to do it. And if you had a driveway that had a little bit more of a slope than that, you would still get some of those benefits from the permeable system. So you would still kind of be getting somewhat of the absorption, but you would be missing out on some of it. And here's a look at a construction detail of these three permeable paving systems that we talked about. And so this is our porous type, our concrete type, and then our paver type or block type. And then the same kind of setup is going to be present for each of these. So we're going to have some kind of coarse aggregate that's going to be kind of the ballast or base for these. And in between, on our concrete pavers, we'll have that in between the spaces to help water move down through. And then we'll have one or at least two to three layers of aggregate. And these are going to be a gradation of different sizes. So we're going from the choker, what you might call a choker course. So these are courses here of gravel that the water is moving through. And the choker course is going to help with filtration. This is going to help with holding and filtration. And then the subgrade is basically, and not all of them have this subgrade. This is maybe for a more intense kind of complex build. Often for paths and kind of residential, we're just going to do the choker course and the base course. But this is kind of putting it to the next level with the reservoir area if we're looking to hold a lot of water, a high volume of water. And so maybe this would be something in a place like Florida, somewhere like that, where they get higher volumes of water during tropical storms, something like that. And then generally there will be a geotextile layer around that to just help with things not growing up into this, trying to prevent roots growing into it, and other things like other debris or things that may compromise this system growing up into our gravel layers here. So that geotextile can be some kind of biodegradable thing or some kind of heavy grade, what you might think of as a landscape fabric, something along those lines. But if you have a geotextile fabric above this where it's filtering out like fine particles or silt or something, that's probably not going to be a good idea. I think I've seen where they've done that, but what happens is you have a buildup of fine particles that could otherwise be filtered out in these layers. And then below that you have your existing subgrade. And we'll talk about maintenance quickly here. So maintenance, annual maintenance is going to be a necessary yearly activity to ensure the longevity and function of our permeable pavement systems. So if it's a open block grid or green kind of grid like that, like we talked about with Missouri Botanical Garden, those will need to be periodically resodded or reseeded. Or if it's a plastic grid with gravel, we'll need to periodically lay new gravel every few years as it's going to migrate inevitably. Now for the permeable pavers and even for the pervious concrete and pervious asphalt, we'll need to do either power washing, where we're just moving out, we're cleaning out the sediment, as you can see here. This gentleman is power washing out these nooks and spaces to clean out things like moss can grow in there, sediments, soil sediments, any kind of junk can accumulate in there and basically turn it into a pervious or an impervious pavement system where water isn't able to infiltrate there. So they also have vacuums here. This is a vacuum system that's sucking that up. And so if we're moving out that fine gravel, we may need to re-sweep new aggregate back in there if enough has been taken out, so that we do have some material in there to fill in those spaces. And then patching may need to be done in small sections with kind of the same or close to the same materials. If there's a degraded part of a concrete or asphalt area, we can patch those up as needed. And then let's look at some cost analysis here. That's kind of a big question that people have. So the costs for these different systems, and it's going to vary pretty widely based on the scope and scale of the project, but generally aggregate pathways, open aggregate pathways. So that's as simple as it gets. That's just open gravel pathway, which also does help wick water away from paths and walkways pretty quickly, but that's going to be the most expensive but the least permanent. When we get into more of the porous concrete and permeable pavers, the cost of that will go up. Total costs range from $2 for like the cheapest permeable asphalt up to $10 or so per square foot for a permeable paver or block system. And that depends on the materials, how much you excavate, what kind of aggregate, how deep of gravel aggregate you're using, if you're using 3 layers, all of that goes into account there. But an average estimate for a driveway with a permeable paver system is somewhere around $5,000, and that's going to again range pretty widely depending on those factors. But they have life expectancies of 20 to 40 years, so they're pretty cost effective, and over time they can return on investment over time, and they can reduce or eliminate the need for adjacent stormwater management infrastructures in things like parking lots and streets. So we're not going to need built up water transportation, like built up gutters or swales or things of that nature, because if this is planned correctly and engineered to remove the majority of stormwater, we're not going to need these ancillary stormwater management systems that are meant to shunt water into stormwater sewers and treatment. So that can pay for itself alone. But those are the basic costs, and kind of that's the details, kind of overview of permeable pavers. And so we do have a video here today, and this is going to be a quick tour and demonstration of our permeable paving systems at the Southern Illinois University campus, where I did my master's degree. So I worked with these quite a bit. And let's get this started here. Howdy folks, and welcome everybody back to another green infrastructure demonstration with our Greening Up Infrastructure series here. And we're back here again at the SIUC campus outside on a nice hot sunny afternoon. And we're looking at a permeable paving system here. So this was installed at about the same time as a rain garden that kind of starts over there, goes along, and goes on behind the camera there. So this is kind of an integrated green infrastructure system. And today it's nice and dry. It's not in action today, but on a day where we're getting a nice heavy douse of rain, then this is really going to do a lot to help pull in that excess stormwater off of our college building here, and to help it kind of naturally absorb back into Thompson Woods here to my right. So this is a layered system, as is the rain garden, as is the green infrastructure series that we've talked about. They're mostly layered systems. So this is a permeable paver system where the permeable pavers themselves are not the porous component. The porous component of this is really what's in between here. So in between the seams or spaces of these blocks is what is helping to suck down and absorb that water back into the soil and back into the ecosystem here, so the plants can use it and it can be filtered and recycled in a more natural way. So underneath here we've got a layer of gravel, so there's about a foot or about a foot and a half of gravel underneath here. So that's really helping to wick away water quickly, give it a place that it can more naturally absorb back into the soil. And in between here there's a light grade aggregate, so a very small kind of grade aggregate, larger than sand. We don't want something in between there that's going to be able to compact and over time turn into more of an impervious kind of situation. So that's kind of how this system works, and this is a pretty common system for walkways and public spaces, kind of where we have foot traffic. So I've got some water here. I just did a quick test to see if it still worked before I did the live demonstration, and that was about a couple minutes ago, and that water is gone. So we'll just run it again here and show you how quickly the water absorbs into our permeable paving system. So I'm not sure if it picks up on the camera, but it is really just draining right down in between the seams or spaces between these blocks. And over time, these do get clogged with
organic material, debris. They can build up things like silt, soil. Sometimes moss can grow in between there, and so they need to be power washed out occasionally or vacuumed out. Somehow we need to periodically clean the debris out so that this functions at its optimal level and works as it should to keep moving stormwater away from our walkways and our impervious surfaces. So that's really kind of the basics of how this one works, and we'll take a quick look at the aggregate tile on the green roof, and that's another kind of pervious pavement system. All right, so we're up here checking out the green roof again, and here I've got one of our composite or aggregate pervious tiles that we use up here on the green roof to move water off of the walkway. So the idea with this system and this product is that it's kind of a combination of polymers and recycled glass. It's a little warm because it is up on the roof here, and it's relatively lightweight, but the idea, and I'll demonstrate this here, is that water should just kind of flow right through it. So I've got my hose going here. We'll see how well this works. So that's good. That's how it's supposed to work. Water flows right through this. That's really kind of the quick water movement and drainage that is ideal for the green roof. All right, so that wraps up our demonstration for permeable pavers today, and thanks for joining us for the Greening Up Infrastructure Series.
All right, we had a quick hat change there. That was kind of interesting. So this is a list of links and resources kind of pertinent to permeable paving that we've talked about today that you'll be sent, and you can kind of check those out for kind of your further personal research. And then we've got plenty of time for questions here. That one was a little bit shorter, but let's go ahead and, oh, and here's my contact info. If you've got any questions later on that you'd like to ask me, feel free to go ahead and contact me, but we'll see if there are any questions today.
So we had one, if you were looking to replace a driveway, would you contact landscapers or driveway installers to do this?
It would just take a bit of research because not every landscape company is going to really be familiar with green infrastructure or permeable paving. I would just kind of look around. You know, it's one of these things where you might have to Google or do an internet search. A lot of times it depends on where you are too. In Southern Illinois, we don't have that many landscape companies or companies that really kind of focus on specifically green infrastructure. Now, when you get closer to the bigger cities, there are design firms that have either specific specialists that work only on those, or specific firms or design companies or landscape architect companies, and that's really their main focus. But it's going to depend on where you're located. But you can always ask, you can say, do you have any experience with permeable paving and that kind of thing? If I would look at a landscape company maybe, but it depends on what their experience is with it. I would probably, if it were me, I would want to work with somebody that's done it before. Obviously, you can try to, and there's even DIY for smaller scale things. But with something like this, you want it to work, and you want it. It is a lot of there's excavating, and it's cost and time, and it's kind of an undertaking. So you want to make sure you do it right. But either one of those construction companies may do it. Landscape design companies may do it, but because landscape design companies, what you realize in landscape design is that hardscape is probably the biggest part of your business, and water features, things like that. But it really is going to depend on the company and what they specialize in. So I would just start to look around. I know in our area, I would look at Green Ridge Landscaping. I think they do some of it in Southern Illinois. But if you'd like to email me, I maybe could help you track down some places to start looking. But I don't know where they're coming from, so I wouldn't know what to recommend.
Okay. And they did just post that they were from Rockford. So, but
Right,
I
yep,
did have
yep.
one more question.
Okay.
Or actually now I might have two. One person asked, what is the maintenance for each of these systems in a northern climate with the snow and ice?
Well, these permeable pavers and pervious pavement systems need less salt on them. They melt, they move snow and ice away from the pavement faster, so they don't need as much de-icer and salt as because they got more airspace in there, so they warm up faster. But the maintenance part of it, it's going to be pretty much the same. And actually, in more northern climates, permeable pavement systems are going to have a longer survivability than conventional paving systems because they withstand that shrinking and thawing, contracting and expanding a lot better than these conventional pavers because they've got a lot more space to move. They've got more airspace, and again, water moves out of them faster too, so there's less freezing and thawing that happens. But as far as the snow removal, it's really just removing snow. It's going to be the same, only ice and snow should in theory melt off of them faster than other kinds of impervious kind of pavements. So really, yeah, but the other maintenance kind of things with kind of the vacuuming and those are sweeping or power washing, those are going to be the same. Those things are going to be the same pretty much anywhere. But in general, they can last, anywhere from 20 to 40 years, and especially in northern climates, you'll get a longer life out of them in theory than something like conventional asphalt or concrete.
Okay. The last question we have is, are there any special licenses needed for a permeable system?
Special license? Well, I mean, if you're an installer, you may need some kind of bonding or some kind of insurance or something if you're out there doing commercial work as a contractor or something. But just in general, I mean, maybe they're talking about installing it, but if you're doing it for your own, personal project, then no, it would be, I mean, you probably have to look at permitting and things like that. Anytime you do some kind of, I think it may be considered some kind of home construction. So you probably do need to check with your city or municipality to make sure that there isn't any permitting. There could be some kind of, small scale construction permit that you might have to get. But other than that, if you're just doing it on a DIY kind of thing. So if you're doing it for a patio or something like that, or a walkway, no, I don't think there would be, unless there's some kind of HOA thing, a homeowners association rule, but that would be something you'd probably be aware of anyway. But it doesn't hurt to check. In general, though, for kind of small scale landscape projects, you should be okay. But if it's something that connects to the street, to the city street, then there may be some kind of permit that you need. So if that didn't answer that, then they can contact me if they'd like.
Okay, and I think that's it. Thank you, Austin.
Okay, well, thanks everybody. Thanks, Maggie. And enjoy the rest of your Friday.